Dr. Tech, and hello to everyone watching this video. This is my submission for the data mining assignment. This is the final submission that covers all milestones. My name is Ammar Alyousfi. In this presentation, we will start with explaining about data acquisition, where we used web crawling, then data management and storage, then data interpretation, then data exploration and analysis. We did multiple types of analysis, and then stock recommendation program. Before we start, uh, let's mention the tools used in our project. We mainly used Python programming language. We used Python and many of Python libraries. For example, we used requests library and beautiful soup library for web crawling, requests for downloading web pages, beautiful soup for parsing web pages. We used pandas library for data manipulation and data representation in Python. We used NumPy for performing calculations on arrays. We used matplotlib for visualizations, textblob library for sentiment analysis, scikit-learn for clustering, Python Twitter library for connecting to Twitter API, as we will see later, and we used Jupyter Notebook in our development to write the documentation and the code and see the results in one document. We also used many Python built-in libraries like Time to control the execution of the program, the regular expressions module in Python for text analysis. Other than Python, we used MySQL database system for data storage, as we will see later, and we used a Python library, PyMySQL, to connect to the MySQL database using Python. We start with data acquisition. We acquire data from multiple sources in order to have a multiple views about on the problem that we are trying to solve. So we crawled stock prices from the Star website and from Malaysia stock.biz website. We crawled tweets from Twitter. We crawled news articles and headlines from the Edge markets and from the Star websites. We crawled quarterly financial data from Malaysia stock.biz website. We crawled company information from Malaysia stock.biz website. And finally, we crawled Malaysian stock indices from investing.com website. For each of these data sources, we created a dedicated Python script to crawl its data. For example, if we look at the stock prices crawler from the Star website, we wrote the Python crawling script and we uploaded this script to a virtual machine rented on Amazon Web Services platform. We scheduled the script to run multiple times a day using cron tab service, and then after that the script run automatically 6 times a day and writes the crawling output to files. This script crawled stock prices data for more than 1,800 KLSE companies. It crawled data for more than 3 months. For Twitter, we use the Twitter API to connect to Twitter and search for tweets and crawl tweets. Um, we used a Python library called Python Twitter to connect to Twitter API, and we crawled tweets that mention the name of any of the 1,800 KLSE companies. To give an idea on the volume of crawled data, we now have more than 1.5 million rows of stock prices data. We have more than 18,000 tweets talking about KLSE companies. We have more than 34,000 news articles talking about KLSE companies. We will later make use of this data. After crawling, we need to store and manage the data. So we wanted to store the data in a MySQL database. To store the data in MySQL database, we created the database first, and then we created a separate table in the database for each data source. After that, for each data source, we wrote a Python script to take the crawled data of that source, structure it, and store it in the database. We drew the star schema of our data, which is shown in this slide. We have the company info in the middle, which has general information about the company. We have a table for stock prices, for tweets, a table for news, another for quarterly reports. So before we move to data interpretation, let's see the database. Here is the database that we created, and here are tables. Each table has the data of one data source. For example, here the star data, we see the rows of the data. So for data interpretation, we needed to interpret the data to know which data is suitable for analysis and which data is not suitable for analysis. So first, the stock prices data from the STAR website. Here is a sample of the data. We can see that each row has the company symbol, the open price of the company, the last price, the high price, the low price, the date and time of the price. We see also that there are some missing values in the table. For example, here, and here. This is because the website doesn't show these values all the time. So sometimes they are missing. But fortunately, the last price column doesn't have any missing value, and this is the most important column for us. So this is the data in, let's say, the raw format. Later we will process this data to get a more useful representation. For Twitter data, after we crawled tweets about KLSE companies, we looked at the data to find that there is a problem, which is sometimes or many times we find a tweet that contains the name of one KLSE company, but in fact the tweet even the tweet contains the name of the KLSE company. It's not talking about this company. It's talking about something else. For example, When we searched for tweets about White Horse Company, we got this tweet, which is talking about blue mugs with a white horse design. So it's clearly talking about something else, not about our KLSE company. Another example, when we searched for MKH company, we found this tweet that is talking about straps, which is different than what we want. Here is a third example, MGB company. We found a tweet talking about this car. So as a result of this problem, we decided to discard Twitter data because we expected that it would introduce noise in our analysis, because we can't know the actual topic of the tweet. Is it talking about the company or is it talking about something else? So we discarded Twitter data. After that, we interpreted the edge market corporate news data. These news data were crawled from the corporate section of the Edge Markets website. So each row specifies the company symbol, the headline of the news article, the URL, the date and time of the article, the text or body of the article. So in uh, this data is relevant regarding our needs, because here if we find an article talking about the White Horse Company, for example, we know that it's actually talking about the KLSE company, not about something else like that tweets. So we decided to keep this data to use it in analysis. Another data that we have, the company information data. This data specifies general information about KLSE companies. For example, it specifies the company full name, the company symbol, the last quarter date, the last quarter revenue, the last quarter net profit, the board of the company, if the company is Sharia compliant or not, the sector of the company, the subsector, the market capital, the number of shares, the return on investment of the company. We will use it later also. After interpreting the data and after deciding which data to use in the analysis, we moved to data exploration and analysis. One of the most important steps that we did in the project is the creation of this table. This table and other similar tables. We created a time series table for each company. This table contains the stock prices and the sentiment polarity for that company for each day. For example, here we see a sample of the table, a sample of the time series table of TM company. Here in the date column, we see that each row represents a different day. For example, here 24th of February, 25 February, 26, 27, and so on. For each day, we have the open price, the last price, the high price, the low price, and the sentiment polarity. The average sentiment polarity of a news articles talking about this company in this day. That is the meaning. After we created this table, we can now uh, after that we calculated the covariance and correlation between the stock prices of KLSE companies. We calculated first we calculated the covariance for all KLSE companies. But since we have a large number of companies, we needed a way to visualize the covariance in a convenient way. So we chose to represent covariance using heat maps. So here we see a heat map for the covariance between 50 KLSE companies. So for example, this square here represents the covariance between this company and this company. So this is an easy way to show covariance. The darker color represents lower covariance, and the lighter color represents higher covariance. This is the covariance. After that, we moved to show correlation. Correlation is the normalized version of covariance. Correlation ranges between -1 and 1. -1 means high negative correlation, where for example, if two stock prices have high negative correlation, they move against each other. When one price increases, the other decreases, and vice versa. +1 represents high positive correlation. In this case, the prices move together. When one price increases, the other also increases, and when one price decreases, the other decreases too. So here is the heat map of all of 50 KLSE companies. In this case, when the color is darker, this means that the correlation is more negative, and when the color is lighter, this means that the correlation is more positive. In this plot, we see that there are companies with really high correlation. For example, here. We also see that there are companies with really weird. So these companies have high positive correlation, and the companies in black have high negative correlation. So we see that there are many companies with high correlations and many company with so we see that there are many companies with high positive correlation and many companies with high negative correlation. To understand the correlation better between stock prices, we will look at examples. In this example, we see the stock prices of two companies. These companies are the prices of these companies have high negative correlation, which means they move against each other. And we can see that from the plot. When the price of one company increases, the other decreases. So these two companies have a correlation of -1, which is the highest negative correlation. On the other hand, this is an example of two companies with high positive correlation. The prices move with each other, so the prices drop together because the correlation here is very positive. The prices are plotted on top of each other. So this is for correlation. Also, we wanted to try to apply data reduction techniques like BAA and SACS. These techniques are used to obtain a smaller version of the data that can produce similar results. So for example, here on the left is the original time series data of DG company. This is the stock price data. On the right side, we see this original plot in gray color, and we also see the PAA representation and SACS representation. PAA in pink and SACS in gold color. But we can use PAA and SACS, but our data is already small. We can easily store and analyze our data. So we don't need the data reduction techniques now, but we might need them when we have a very large data. Now, uh, now that we have stock prices data and we have sentiment polarity data. For sentiment polarity uh, ranges between -1 and 1. -1 means the sentiment is negative. For example, the sentence, this company is bad, this has negative polarity. Polarity of +1 means positive polarity. So polarity, sentiment polarity, ranges between -1 and +1. So as we said earlier, we applied sentiment analysis on the news data and took the average sentiment polarity for each company for each day to put it in the time series table. So now we have the stock price data and sentiment data. We wanted to plot the stock price and sentiment with each other to see how the price and sentiment are related. So in this example, we plotted the sentiment and stock price of FGV company, the stock price in blue color and the sentiment in red color. And here on x-axis, we see the date from 20 of February to 15 of May. So we can see that there is a relationship between the stock price and the sentiment. For example, here we see a drop in sentiment and a drop in stock price. Here we see a spike in sentiment and a spike in stock price. Here also, here also, here also. So we conclude that there is a relationship between the two. And it's a question that can we predict the price from the news? Here we show another example of Gamuda company. We see also that there is a relationship. Here they drop. Here we see spikes in sentiment and price. Here also spikes. But if we look at this example, we see that the situation is different. For example, here we see a spike in sentiment but a drop in stock price. Here we see a spike in sentiment but nothing in stock price. Here we see that we have a spike in both of them, and here a spike in sentiment and a drop in stock price. This might be because we need more data for our analysis, or because we need to follow a different sentiment analysis technique that is more suitable for news data. We need to investigate more about this issue. So here we plotted the stock price and sentiment. We also plotted the stock prices of two companies with each other to compare their prices to see if they are related to each other, if they move together. For example, here the stock prices of Sunway and Aeon, we see that they move against each other. When one price is high, the other is low. When the other is high, the first is low. So they are in opposite directions. In another example, here is the stock prices of Maxis and DG. We see that they have some correlation, uh, like they move together, as we can see. This might be because they are from the same sector, which is telecommunication companies. This might be the reason. We also plotted the open price and last price of the same company to see the relationship between these two prices. For example, here we see the open price in red and the close price or last price in blue. These prices are of Dialog company. We can see that the open price is shifted to the right from the last price, and this is logical because normally, I think normally, the open price of the day is the last price of the previous day. But we also see that this might not be the case always. For example, here we see some we see a different case. Here also, here also. So it might depend on many factors. After that, we moved to clustering. We wanted to apply k-means clustering on company data to find groups of similar companies. To do so, we cannot apply k-means clustering on time series data. It will be not meaningful. So we needed to extract data from the time series of the companies in order to apply k-means clustering. And we did that. Here is a sample in this table. We extracted, for each company, we extracted the average last price of the company, the standard deviation of the last price, the last price minus open price, the minimum last price of the company, and so on. So now for each company now is represented in a separate row. In this way, we can apply k-means clustering. So we chose the number of clusters to be 3, and we chose 2 extracted features to be used for clustering: the average last price and the standard deviation of the last price. And here, of course, we used Python as usual to do clustering using scikit-learn library. Here we can see the results. On the x-axis is the average last price. On the y-axis is the standard deviation of the last price, and each point represents a company. And the color of the point represents the cluster. We have 3 clusters and 3 colors. So here are the clusters. We can see that they are separated. Like this is one cluster, this is the second cluster, and this is the third cluster. This arrow here points to AirAsia company, just for example. We have also another visualization for clustering, which is here. Here the area of each cluster is in different color, and also these marks, the X marks, represent the cluster centers. Yeah. So clustering might help us to to group companies into uh, into similar groups. For example, this cluster, we assume that these companies in this cluster have have common attributes between them. This might help in understanding the stock market better. Also, we did something similar to clustering, where where we used a program from scikit-learn to to represent the structure of the stock market. To do so, we used 50 KLSE companies and many techniques. For example, we used sparse inverse covariance to find which stocks are correlated conditionally on other stocks. We used affinity propagation clustering to group together the stocks that behave similarly, and also we used manifold learning to obtain the 2D embedding for visualization, to produce the 2D visualization so we can see it. In the plot that we will show now, the color of the nodes represent the cluster, and the edges between nodes represent how stocks are conditionally correlated on other stocks, and the position of the nodes is obtained from the 2D embedding. Here is the plot of the structure of the market. Let's see a more clear one. Here, as we said, the color of the node represents the cluster. So these nodes belong to the same cluster. And the edge, the strength of the edge, represents how the stock is conditionally correlated with other stocks. The edges in the plot have different strengths. This structure seems complicated, but it might give us important insights about the structure in of the market and the relationships between different companies. Now we go back to the presentation. So in the final step of the project, we produced a program, a Python program for stock recommendation. This program searches all stock prices of the companies, of the KLSE companies, to find the stocks whose price was high and dropped recently and then started to rise again, as we will see later. We assume that these stocks will give profits to the user if he invests in them. And the program recommends stocks that are compliant with the Sharia to give suitable recommendations for everybody. And along with the recommendation, the program gives useful information about the company, and it shows the price of this company over time. So when we run this program recently, we got these recommendations. The first recommendation is Pansar Company. The program displays the company full name, the company symbol, The board of the company, which is main, uh, it tells us that it's compliant with the Sharia, and the sector of the company is industrial products and services, and the subsector is building materials. The program also tells us that this company achieved this amount of money in the quarter of 31 December 2018. And here is the plot of the stock price of this company. We can see that it was high, then dropped recently, then started to rise again in the last few days. So this might give the user more profits if he invests in this stock. The second recommendation is this company, and we also have similar information and the plot of stock price of this company. That was the presentation for my project in the data mining assignment. Along with this presentation, with this we have this Jupyter notebook. This Jupyter notebook includes the most important steps in the project. We have the code, the output of the code, and we have also explanation about different concepts in the project. So this will also be submitted, and along with that we have the report of the project, which describes what we did and in the different stages of the project. And also we have the Python code and scripts that were used in this project, and they also will be submitted. Thanks for watching.